physics is in meters, right? Yeah, so I'm gonna. Wait, feet per inch? Wait, is it meters or feet? Why are you saying feet and inches? Messing me up. Oh, okay. Me neither. Imagine doing that. Okay. So I'm gonna do. This is like not in the note part of your book. So if you like have room to write it down, great. If not, you can just watch. I'm going to derive. I assume that you guys have seen. I guess I should ask Rod. But this, I think, is an equation in like non-calculus based physics. Is that familiar? Okay. So I want to derive that. I want to like show you where it comes from. I didn't teach the lesson. There's not really a ton new in this lesson. It's like combining old stuff with integration and velocity acceleration and kind of just putting it together. But this is a good exercise to like see how this works and find that formula. So let's say I start with just I know A of t equals negative 9.8. So that's gravity. Negative 9.8 meters per second. Well, if I integrate area, that'd be the integral of negative 9.8. What do I get? Say two things actually. So negative 9.8 t plus c, and because I've integrated acceleration, where am I now? I'm at velocity. Well, the next thing I know is that, and it's kind of just saying the same thing twice, but this is saying the velocity when your time equals 0. We're just going to call it v naught. Is that what Rod calls it? V naught. Okay. So then that means when v is 0, or when t is 0, the velocity is v naught. So what does c have to equal? It has to equal v naught. What we have now is that velocity equals negative 9.8 t plus v naught. Agree? If I integrate velocity, where do I go? Let's integrate both sides. What's the integral of velocity? Position. Let's call it x. And the integral of negative 9.8 t would be negative 4.9 t squared. The integral of v naught, that's just a constant, would be v naught times t, and then plus c. So that's why it's 4.9 in the equation, because I always thought it was weird. Like, gravity is 9.8, why do we end up with like half of that in the formula? And that's why, because you're integrating, so you add 1 to the power divided by 2. And then if I plug in 0, I get h naught. So c equals h naught. And then we can plug back in and find the what I wrote out a second ago. X of t equals negative 4.9 t squared plus the initial velocity times time plus the initial. So that's just starting from all I started with was gravity, and then worked my way back up, and I got that equation. Right, so that type of thing is what this lesson's about. Let's look at the ones that they have in the notes. So number 1, we got a particle with acceleration, then they give us information about velocity, information about the position. We gotta find out the position function. So I'm in acceleration, so I'm gonna have to integrate. There's gonna be a c. I'm gonna get enough information to find the c. Then I gotta integrate again, another c, and I find that c. So I have acceleration equals 12t minus 4. So if I integrate both sides, I will have that the velocity equals 6t squared minus 4t plus c. And then if I'm going to find out what c is, I have to have some extra information. What they're telling me here is the velocity is 18 when t equals 2. So that becomes 18 equals 6 times 2 squared minus 4 times 2 plus c. The 18's from right here. And then, so what do we got? This is 24 minus 8, so this is 18 equals 16 plus c. C equals 2. So now I can go back here and be like, that's not a c anymore, that's 2. I can be like more accurate now because I've used the extra information to find out what c is. But now I've got to do it again, because I'm at velocity and they're asking me about position. So I'm going to write this over here so I don't forget it. I'm going to clear that all out. So my velocity is 6t squared minus 4t plus 2. And I want to get to position. So how do I go from velocity to position? Integrate. Think about integrating both sides. The integral velocity is position. People use x a lot, or you can use h for the height. And then integrate here. So I would have 2t to the third minus 2t squared plus 2t, and then plus c. And then they tell me the initial position, so what is time if it's the initial position? It's 0, because like you're starting them out. Okay. So, the initial position is 8, and that happens when time equals 0. Which basically tells you c equals 8, because all the other stuff just like goes away. Oh, really? Like the functions aren't valid unless. Really? Okay. Yeah, I'm not going to convert it. Yeah. Deal with it. Well, it makes it easier, but it's just. You're just not used to it. So then you just like rewrite it, and you throw in the number in place of. So it's plus 8 then. That would be your final answer. So there's 2 levels. You do the same thing, just doing it in 2 levels. Sometimes they'll give you like the actual point, like this was 2, 18. Sometimes they'll tell you initial. If they tell you initial, then you gotta know that t equals 0. Is that okay for 1? Alright. T89 time. Type that in your calculator. Graph it. I don't care. We're gonna integrate. I don't care if you graph it or the other way. I'll review both ways.
Also,
I didn't hear you say. Or maybe making the mistake of correctly. Who stole my TI-89? Did you actually? Like I have it up here. Do you guys need me? I don't have a calculator. Did you say ha-ha? Give me your calculator, dude. Damn it, it's mine anyway. What, Antonio? I mean, I was gonna show you. It's fine. I just kind of. Oh, there it is. All right. So there's two ways you can do it, but realize that if you graph it, the screen, the area that you're integrating has to all be on the screen. So like when I see the 0 to 10, I'm like, okay, cool. Usually 0 to 10 is on the screen. When I see 0 to 30, that's not really on the screen anymore. So I'm gonna have to zoom way out to see it. Which for me makes me say I'm not going to do it the graph way, I'm going to do it the other way. But that's like everyone's different on that. You can do it the graph way as well, but you'll have to zoom out so that it can see what it's integrating. If it can't see it, I mean, it's a freaking computer. It shouldn't matter if it can see it or not, but it does. What? I mean, it has some flaws, but you can have flaws and be good. Those can both be true. Like you, for example. Like anyone in here, for example. Yeah. Alright, so I'm not going to use the graph. I'm going to go calculus, integrate. I'm just going to type it in. Before I do it, you want to be in radians, which it kind of tells you right there. So if yours says like DEG, you want to flip that. You want to change that. So all I did was type F3, and I'm just going to type in the equation. You can use X's in place of the T's if you want. I'm going to use the T. Just because I think it looks cool. ln is second X. So, a couple things. I did it in T's, so I put a T here. You did it in X's, you put an X there, but you can't mix and match. You can't put like an X there and a T there. It'll give you an error. And then you put I think the question said like in the first 10 minutes, right? So we're just integrating from 0 to 10. Should get that, 3.01. How many are getting 3.01? We okay? 3.01. Did you get that? What does that mean? Okay.
I swear this name was on the last.
Mr. Brust?
Yeah.
That's the guy that wrote it. Like this whole book.
Yeah. There's
Yeah. Well, no, not T equals. We didn't find time. We found distance, so it's like miles. So, a couple things. This is a velocity graph, so this was miles per minute. Remember when you integrate, you drop off one of the denominators. So if you integrate miles per minute, it just goes to miles. That's 3.01 miles. Part B and C, you're just plugging in, like you just do 0 to 15 and 0 to 30. Is that fair enough? Just change the 10 on the previous one, the expert, to a 15. If you hit second enter, it'll give you like an instant replay. It'll pop up whatever you just typed in. Then you can just scroll back and change the 15 to a 10. Or 10 to a 15. 10 to a 30. So B and C are fine, right? You just change it like the last number. Okay. D is a little different though. Do you want to do it? That would actually be like even. That would be really funny. What is Packard? Oh, he doesn't use this, does he?
He sits on the chair. Where are you going over here right now?
I'm about to. I'm finna. People still say finna? Okay. So this dude driving to Mr. Rust's house, wherever he's driving, didn't really know where he's going, it looks like, because this is supposed to be like the distance to Mr. Rust's house. Is that what that is?
Oh yeah, that is a good point.
But the idea I'm trying to get across is this person went backwards at first. How do I know they went backwards? I couldn't hear anyone else because you had to make that joke, which wasn't even funny. What? 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 Yeah, so we're going backwards, then we're going forward, then we're going backwards, then we're going forward. Please stop talking. For example, if this is 2 and this is 1 and this is 5 and this is 10, so 1. When you integrate it from 0, I don't even know what this is, but let's just say this is the integral we're doing. What would the integral from here to here tell you? What would it give you? It would give you 12, because the 5 and the 10 are positive and you subtract the 1 and the 2 because they're negative. Part D is not asking that. It's saying how many miles did you drive. So, like, even if he went backwards, he drove, right? He used fuel during that time. So what we want is for these negative values to become positive. So they count. How do I make anything positive? That's the value. So if you integrate from 0 to 30, the absolute value of sine of 0.3t plus ln of t plus 1 minus 2 times dt. That'll take these little areas down here, flip them up and make it positive, and then they count as positive miles driven, which they should because we did drive them. You guys know how to do absolute value? You're going to hit integral, and then it gives you a parentheses, right? And then put ABS. Yeah, I'll show you how to do that. It's not the vertical line. I go to catalog. I think it's in math too, but so I'm going to go F3 integrate. And if you hit catalog, it usually just dumps you into the whole list. That's every command in the calculator in alphabetical order, and ABS is like the first one. So I just do that. And then everything I type in that parentheses is inside the box. You'll have like a double close at the end. Here, let me show you. So, absolute value of sine of 0.3t minus ln, yep. Stop arguing so much, man. So, I should have that. I'm not done, but like, there's my, that's the absolute value part. There's those parentheses, this one and this one. So I still have to put, oh yeah, minus 2. Yeah, mine's still busy. That one's done. How long did it take? I don't know if you're joking or serious. You're dead serious? Probably depends on your battery strength. Oh, there we go. Did you guys get this? 28?
28.
Is it from 0 to 30?
0 to 30. Oh, I got it. Oh.
Are you sure it's not on it?
I have that exact line as well. I also have 497. Yeah.
Let me see what you took.
Isn't it plus?
Oh, is that? Oh. I was just looking for like syntax errors. Now we gotta wait 20 minutes again.
I don't know if I can take that one.
I think you must have fresh batteries. I think it's the more dead your batteries are, the more screwed you are. There we go. 28.49 on. Okay. So numbers not really like my main concern. It's like, do you understand? So if we integrate velocity, we get displacement. And if we integrate the absolute value of velocity, we get distance. We talked about this before. Displacement's like, I walk from here to the back of the room and back. My displacement is 0. My distance would be like the amount that I actually traveled. So it'd be like 20 plus 20, whatever. Alright, then I want to do 3. Then I think we're good. Am I okay to go 3? Okay. Well, you look like you're about to ask something. Okay. Okay. Oh, there's 4. So, I know that the starting amount here is 5. And then I need to find the position of the particle after 3 seconds. So there's a couple ways to get to this, but by far the easiest is this general idea. It's going to be like the initial value plus the integral. Yeah, I don't know how else to say it, except initial value plus integral. So I know that at the very start of this particle's experience, he is at 5 units, he or she. And then for 3 seconds, it travels at this velocity. So to find out the displacement, I would just integrate it. 14 to the third minus 60 squared plus 1. And I'm literally just doing that in my calculator and typing it in, and I'm good. So I know this is where it was at the beginning. So this is my initial value. This will tell me how far it traveled. So you add that to the 5, and you get whatever it is. Should I integrate in the calculator? Okay. Can I get rid of this, or I want to still write this? Say no. Okay. I don't know. I might need it.
You can't ask this.
It's in my book. Alright, so I'm going 5 plus. I would strongly recommend putting the 5 plus in there because I think a lot of times people are like, oh, I'll just integrate it and then I'll add 5 at the end. When you totally forget to add 5 at the end, your answer's wrong because of that. I'm going 5 plus the integral. 4t to the third minus 6t squared plus 1 comma t, that's like your times dt, and then 0. So I got 35. 35? That's cat. So then part B, really similar idea. So my initial amount here is -2. So this experiment starts when time equals 1. So that's all I know. I don't know the position at 0. I know the position at 1. And then they're asking me about 2. So I'm going to integrate from 1 to 2. I know where we are at 1. We're going to travel to 2. So I take my initial amount plus that amount that I accumulate. So -2 is the start plus integrate. Same thing. So 4t third minus 6t squared plus 1 t comma 0. No, sorry. Comma 1 comma 2. So I knew where I was at 1. Integrate from 1 to 2 and add that amount to it. I got 0. You guys get 0? Okay. Yeah. Oh, sorry. Okay. Yeah. Questions on A or B then? All right, number 4. There's a bunch of different ways to do number 4. Try to do like the most efficient. If I asked you to integrate from 0 to 4, what would your answer be? It'd be 0, wouldn't it? Because this area up here is positive, this area down here is negative, but they're the same size. So they would just cancel out. And if I said integrated, it would just be 0. Or if I said displacement, but it's saying total distance. So I think the easiest way to do this, like these are symmetric, right? These two parts. So I'm just going to find one of them. I'm going to find one of them and then just double. And it says show your work. I'm not concerned with that right now. What I'm more concerned with is can you use the calculator. So keep doing it in the calculator. Keep practicing your calculator. So I'm going to do 2 times the integral from 0 to 2 of negative 1.5t plus 3. Or, do I need calculus for this problem? I'm making this smart. Do you need calculus for this? Like this is like a regular, let's go generous and say honors physics question. It's just that, what's the area of that triangle? 1/2 base times height, right? 1/2 times 2 times 3. The area of that triangle is 3. The area of that triangle is 3. So the total distance would be 3 plus 3 equals 6. Or you can do this, and that would tell you 6 also. Main point is the total displacement, or total distance you have to do different. You could also do integral from 0 to 2 of the absolute value of negative 1.5t plus 3, because that would take this part and flip it up, and then you're adding up these two positive areas. So now that I've explained it 4 ways in like 4 different spots, you can use it. Is there a question I can answer on though? Yeah, this one would be 4. Or I could have put it times 2 in the front, right? Like either way. Yeah, thank you. Okay. That's all I got. I want you. We're gonna spend a couple days on this, so I want you just to go up to number 8. Let's go up to 8. Mighty generous of you. 1 through 8. Where are you rest of next year? Oh, really? Big time when you first started? Oh, yeah, that's a huge It's like she was saying.
What's wrong? Why is that in Canada?
Would you do like law or something?
Wait, what do I do?
Do what? Is that like all the That's not like how it works, but kind of. Right. Have you been before? Is the calculator getting like a little easier? Ish, kind of, maybe some. Not saying you're a pro at it, but more we use it, about it'll get. Do your work.
I am. They signed me out of school, so I decided back in.
Yeah, why did every single person get that? You guys all get that?
Oh yeah, I got signed out.
Why that?